Hello and welcome to Calculus Lecture 1.3D, where we're going to talk about trigonometric limits. So you're going to have to learn some formulas for this lecture, and this lecture just has a bunch of example problems. And really the formulas are related. It's really just two formulas. The first is the limit as x approaches 0 of sine x over x is equal to 1. And then the reciprocal of that, x over sine x, also equal to 1. If we put a constant in front of the x, the limit of sine cx over cx is equal to 1. So let's say that's a 3. So sine 3x over 3x is equal to 1. And the reciprocal of that also equal to 1. And then the only formula I have to memorize involving cosine is the limit as x approaches 0 of 1 minus cosine x over x equals 0. And then you need to remember a few trig identities, such as tangent x is sine over cosine x, cosecant x 1 over sine, secant x 1 over cosine, and then cotangent is 1 over tangent, which would also be cosine over sine. And let me fill in this spot with one last one, the trig identity that you hopefully remember from pre-cal. And that's sine squared x plus cosine squared x. Do you remember what it is equal to? It is 1. All right. So we're just going to be using these formulas and working a lot of example problems. So our first one, let's say we want to evaluate the limit as x approaches 0 of sine 3x over x. Now that's not exactly what I need, is it? Because I've got a 3x on top and just an x on the bottom, and I don't have a formula for that. Well, what we do with these trig limits, the way we deal with them, is we just kind of manipulate these equations so that they fit one of these identities. Okay, so how about we rewrite this as the limit as x approaches 0 of sine 3x over x times 1 over 3. That allows me to bring that 3 right here, and then I have it in the format that I need, sine 3x over 3x. However, if you multiply an equation by 1/3, in order for it to be the same, we must compensate by multiplying by 3 over 1. Okay, so now this is exactly the same as this. I've just broken it up a little bit. So now we have the limit as x approaches 0 of sine 3x over 3x. I went ahead and brought that 3 right there. And I'm just going to leave this 3 over 1 separate. So that's just the same thing as this. I've just rewritten it. Well, the sine 3x over 3x, we have an identity for that. That's 1. So this would be 1 times 3, and that is 3. So the answer to this question is 3. All right, let's try another one where we have to do a little more manipulation. Let's say the limit as x approaches 0 of 3x over sine 5x. Okay, I'm going to rewrite this. I'm going to break this thing up so that I can use these formulas up here. So let's rewrite this as 3x over 1 times 1 over sine 5x. That's the exact same thing as this, right? Now that helps me see what I need to put right here. What I need right here where that 1 is a 5x. So let's multiply this by 5x over 1, and then I can put a 5x right there. But that's not legal unless I do what? Multiply the whole thing by 1 over 5x. Because 5x over 5x is just 1, right? So by doing this whole section, I didn't change the equation. I just wrote it out so that I can see it better. So that would give us the limit as x approaches 0 of 3x over 1 times 5x over sine 5x times 1 over 5x. Okay, I brought that 5x to right here. Okay, I'm going to rewrite this. I'm going to simplify this even a little more, because what happens now? The x here and the x here cancels, doesn't it? So we have the limit as x approaches 0 of 3 over 1 times 5x over sine 5x times 1/5, because those x's canceled out. Well, the limit as x approaches 0 of just a constant is that constant, so that would be 3. This 5x over sine 5x is just this formula, so that's 1. And then the limit of 1/5 is 1/5. So the answer is 3/5. All right, so all of this is kind of just wishful thinking. You know, we're putting in what we need to get to the formula, and then we're compensating to make the equation mathematically legal. All right, going to do a lot of examples today. Let's go for the limit as x approaches 0 of sine 4x over sine 2x. Now I want to break this up right at the write it so that it's the exact same equation, but break it up so that I know what to do in order to get what I need. So how about we write it as sine 4x over 1 times 1 over sine 2x. What do I need to be down here? Well, in order to match the formula, I need a 4x. So let's multiply by 1 over 4x so that I can get that 4x right there. And then what do I need to be here on top? I need a 2x. So let's multiply by 2x over 1. And I have a 2x in there. Now what did I multiply this whole thing by? I multiplied it by 2x over 4x, which is just, the x is canceled, that's 1/2, right? So if I multiplied the whole equation by 1/2, then to compensate I have to multiply by 2. Okay, so now let's rewrite it by kind of putting it all back together. So I'd have sine 4x over 4x times 2x over sine 2x times 2. And then using the formulas, that's going to be 1. This is going to be 1. And this is 2. The limit as x approaches 0 of just a constant is the constant. So that's 1 times 1 times 2, which is 2. Pretty cool. All right, let's do one now. On those previous 3 examples, if you plug in 0, you would get 0 over 0. If you always want to do that first, and I kind of skipped that step. But sine of 0, 0, sine of 2 times 0, sine of, you're going to get 0 over 0. That's indeterminate form, and we needs more work. But sometimes you'll get one of these where you can just do a direct substitution. So let's say we have the limit of, as x approaches 0, of x cosecant 2x over cosine 5x. Now, before I try to start, turning that into 1 over sine and doing a lot of manipulation, how about we just plug in? So if we'd have 0, the cosecant goes with sine. Sine of 0 is 0, so cosecant of 0 would also be 0. And then the cosine of 0 is 1, so that's 0 over 1, which is just 0. So it didn't need more work. We could just directly substitute and get an answer that was not 0 over 0. So be careful if you have a homework problem like that. You don't want to do a ton of work if you don't need to. All right. Let's move on to some more examples. All right, let's try the limit as x approaches 0 of x plus x cosine x over sine x cosine x. Now, I hope you can see, sometimes we have to use a little algebra on these things. And I hope you could see that you could factor an x out of the top, and that might be really useful. So let's factor an x out, and then you'd have 1 plus cosine x. Right? If you're not sure you did that right, just distribute the x, and you get x plus x cosine x over sine x cosine x. Now I want to rewrite this thing so that it looks like one of these formulas. So how about I rewrite it as x over sine x times 1 plus cosine x over cosine x. If I multiply those two together, that times that gives you this. Okay, I just broke it up, and now I have x over sine x, which we know is 1. Now this is going to be 1 plus the cosine of 0 is 1 over 1. So that's 1 times 2, which is 2. All right, looks real bad, but it's not so bad. Okay, let's see if I can squish in another one here. Let's say we have the limit as x approaches 0 of tangent 7x over sine 3x. Okay, anytime you see tangent, I don't have any tangent formulas here, but maybe I should switch that to sine over cosine. So I'd have sine 7x over cosine 7x over sine 3x. Now we can take this bottom one, because it's like multiplying by 1 over sine 3x, and the shortcut is just move it up a level. So sine 7x over sine 3x cosine 7x. Okay, now I got it into sines and cosines. Let's break it all up and see if we can make it look something like one of these formulas. So we have the limit, and you do have to write limit every time. How about we write it like this? Sine 7x over 1 times 1 over sine 3x times 1 over cosine 7x. That's the exact same thing as this, right? Now I know what I need to put in, though. I know I need a 7x right here, so let's multiply by 1 over 7x. I know I need a 3x on top, so 3x over 1. Now I've multiplied by 3/7, so what do I need? If I multiply something by 3/7, I've got to compensate by multiplying by 7/3. Okay, so I was wrong. I can't squish that in, so I'm going to erase this real quick and finish the problem up in this top part. Okay, so we're going to rewrite this as the limit. it's hard for me to write this and not accidentally erase what's beneath, as x approaches 0, of sine 7x over 7x times 3x over sine 3x. And so all I did there was bring that 7x there and bring that 3x there. Now I've got to multiply by my last compensation, which is 7/3. So that's 1. That's 1. And that is 7/3. So the answer is 7/3. All right, that one took a little bit of work. Okay, still got some more examples. Want to make sure that you're ready to do well on the homework, so I'm going to give you a lot of examples. 3 more, in fact. So let's do the limit as h approaches 0 of h over tangent h. So, of course, that'd be 0 over 0. Let's change the tangent to sine over cosine. And now you can bring that cosine up a level. So that's the limit as h approaches 0 of h over sine h cosine h. Just brought that cosine h1, I wrote sine first. And now I hope you can see you can break this up and make it look like this formula right here. So we'd have the limit as h approaches 0 of h over sine h times 1 over cosine h. So we know this is 1. Cosine of 0 is 1, so 1 times 1, and that is just 1. Okay, the next one definitely I need a little room for, so I'm going to go ahead and erase this. So let's try the limit as x approaches 0 of x squared over 1 minus cosine x. Okay, that'd be 0 over 0 if you plug it in. So let's, this one is tough. You don't have a formula that looks like it. You might think, oh, x over 1 minus cosine x is equal to 0, but the reciprocal of 0 is not 0. So what you have to do is, let's multiply by the conjugate. That's one of your mathematical tricks. Multiply by a conjugate. So just a clever version of 1. So we're going to make that 1 plus cosine x. Okay, so I'm going to FOIL that out. So you'd have x squared times 1 plus cosine x on top. And on bottom, we're going to FOIL. So it's 1 times 1. Then the negative cosine x and positive cosine x cancel out. And then that'd be minus, the last would be cosine times cosine, so minus cosine squared x. Now over here, down below, if you have sine squared x plus cosine squared x equals 1, then sine squared x is equal to 1 minus cosine squared x. Okay, so we can just rewrite that as sine squared x, the denominator here. So I've got the limit as x approaches 0 of x squared times 1 plus cosine x over sine squared x. And then I'm going to break this up as x over sine x times x over sine x because that's just x squared over sine squared, right? Those two, I didn't do anything illegal. 1 plus cosine x over 1. That's the exact same thing as this, but now the way I wrote it, I can see these identities here. So that's going to be 1 times 1. And then the cosine of 0 is 1, so times 1 plus 1 over 1. So that's 1 times 2, and that is 2. Okay, a lot of work to that one. So remember, you can do conjugate, would be one of your mathematical tools that you can use if you just kind of get lost and not sure what to do. You can always try that. Okay, last example. Got the limit as x approaches 0 of 2x plus sine x over x. Now we just have a single denominator here, so this is really easy to break up. You can call this 2x over x plus sine x over x. It's the exact same thing as this. We just split the fraction apart. Well, we know the limit of x approaches 0 of sine over x is 1. 2x over x is just 2. So that's 2 plus 1, right? That's just 1. And that is 3. Okay, the homework, we'll call this 1.3D. I think we actually have 5 separate homeworks for section 1.3. We're on page 65. And you want to do 57 through 68. You're going to do all of those. So the odds are in the back of the books. You can check those. And then the evens, you can look at the answer on the solutions video. So that's all. That completes the trigonometric limit lecture. And I will talk to you next video.